Welcome, everyone, to this special webinar on overhead power distribution and also best practices in modular design with Starline, Chatsworth Products, and, of course, University of Florida Health, helping us understand where we need to be looking, what the pros and cons are, what the benefits are, and how we can actually look at so many multiple challenges that we're facing today with operational excellence and capabilities. So my name is Stephen Warren, and I'm the CTO of Data Center Dynamics, and I'll be your moderator today. So today's webinar really is going to help you understand in a three-phase process before we get to that round table what you need to be thinking and how we need to be working for it. So please remember, this is a 60 minutes today. It's broken down into 4 parts. We're going to have two presentations, a bit of a discussion with Joseph Kino over at University of Florida Health, and then we're going to be jumping into that round table. A few quick notes. Yes, the webinar is available for download and replay, so spread the word to your colleagues. And don't forget to get in your questions to our subject matter experts for the round table via the question button on top. Also, please note that we will be having two poll questions throughout the webinar, so please remember to vote when I announce that the poll questions are going to be done. Also, at the end of the webinar, you'll have that additional time to connect with them also via email. We'll be providing that information, Twitter, etc. And, of course, that opportunity to download a fantastic white paper to help you understand everything that Starline and Chatsworth have been doing. There's a real urgency here, folks, and organizations really need to be enabled for the on-demand, changing, capacity-driven, load-driven data center digital economy. This is more than just applications in digital world. This is really understanding how you can prepare for the future. And that's evident by the fact that we have well over 250 people joining us today on this international webinar. So let me get started by actually introducing our fantastic subject matter experts. Today I'm honored to be joined by Mark Swift, Stephen Braunfield, and also Joseph Kina. Mark Swift is the Director of Marketing at Universal Electric Corporation Starline. I got to say this about Mark. For those of us who have been in the industry a long time, we know Mark. Mark's been the Director of Marketing for all of Universal Electric Corporation's products and services. He's got that responsibility for that global strategic planning, the business development activities. But more importantly, Mark is the guy who we always see listening to us about what our requirements are in our facilities. So, Mark, thank you so much for taking the time to join us today.
Oh, thank you, Stephen. I'm excited to be here.
Excellent. Thank you very much, Mark. And I got to say, Stephen Braunfield, an absolute pleasure to have you join us. Stephen's been with Chatsworth for quite some time, but I got to tell you, folks, if you don't know, I remember Stephen when he was at Intel for over 25 years. I apologize on that one, Steve. And during that time, you really were the man that was behind not only the state-of-the-art design and construction of not only clean rooms, but data center twos. And he was, Stephen, you were the man responsible for driving us through new technologies, new designs from where you were and face-to-face in the industry. Stephen, thank you so much for joining us today.
Steve, thank you so much for allowing me in, and I appreciate everyone's attendance.
Fantastic. And last but not least, I got to say, Joseph Kina, you are so critical to this discussion. Joseph is the manager of data center operations at the University of Florida Health Shands. And folks, this is a level 1 primary care facility for the entire Southeast. Over 10,000 employees, multiple hospitals, multiple data centers. This is cutting edge, what I would call real life and death mission critical application requirements. So, Joseph, for you and your entire staff and everything that you do at the University of Florida Health Shands, thank you for keeping so many people alive and keeping healthcare driven to the latest and greatest that are needed in our industry. So, Joseph, thank you so much for joining us today.
Thank you, Stephen. Appreciate it.
Wonderful. Mark and Stephen, we're going to be turning over to you guys in a moment. But first, why don't we actually get to our first poll question? So, folks, if you could, you'll be seeing on your screens a poll question come up, which is, would you design a data center without a raised floor? So if you had the opportunity right now to design a new data center or take over a section of your data center, would you do it without a raised floor? And for those of you who actually, this is dream world, folks. This is an opportunity for you to express your opinions. Is it yes, no, or would it be a combination of those? So please start voting. We'd appreciate it. And what I'm going to do is, I take the next 2 minutes just to give you a brief outline of the agenda for today. So modular data centers continue to grow in popularity, bringing with them a wide range of benefits. We know that. In fact, I just got a call from a very large government agency a week ago asking me how they could take care of legacy tape equipment. They couldn't even find anybody that could assist them in the humidity area or even in the new requirements for the capacity and power. So they were looking at modular designs. They were looking at overhead power distribution as an option. So conversely, a number of pitfalls lie ahead for those people who don't understand what's happening in the market, not least in the area of power management and distribution. So what we're going to do today is we're going to have Mark Swift walk us through the benefits of power distribution. Then we're going to have Stephen take us through the best practices in modular design. Both of these presentations are short, tight, and full of great information that you're going to want to listen to. And then we'll get to Joseph, where he's going to give us a brief overview of what's really gone on at the University of Florida Health and their fantastic work. Then we'll be opening it up to the roundtable discussion for all three gentlemen. So let's take a look at the votes and what they were, and I've got a response here. And the results are in. About just under 50% say A. They actually would, yes, design a data center without a raised floor. Another 40% say no. They would do it with a raised floor. And only about 15% is a mixture of the solutions, both raised and non-raised. So, Mark, I'd like to turn things over to you, if I could, and take that on board with you when you start talking to us and help us understand what's going on these days with the challenges and the opportunities and the solutions. So at this time, Mark, it looks like about 50% would build a facility without a raised floor. So let me turn it over to you. Mark Swift, thank you so much for joining us, and let's start looking at the benefits of overhead power distribution.
Thank you, Stephen. That is interesting feedback from the attendees here, and we're going to talk about that and why you might want to consider. It seems like a lot of people are considering not using raised floor in their application, but just some other items to take into consideration there, not only from a cost perspective, but also from a modularity perspective. And really what I want to do here is frame this discussion as far as the power distribution piece in that frames, in that mindset of looking at it from a modular approach and how you can really increase the length or duration lifeline of your facility when you incorporate a lot of these modular design characteristics into your power distribution. Just a quick comment, definitely excited to be on here with you guys, as well as Stephen Bornfield from CPI and Joe Kina. It's been a great opportunity to work with them on this installation, and we're excited to review that, the specifics on that later on in the presentation here. So we're definitely going to try to share some of the insights that we had there. I want to talk a little bit on the front end here about traditional power distribution. We've all seen these facilities before that embrace the traditional power distribution approaches, incorporating a raised floor with RPP units deployed throughout the facility. You can see there in that image on the screen, traditional back looking into the RPP with all the cables coming up from underneath the raised floor. Then those cables, those whips go out to feed the various cabinets on the raised floor. And, typically you have to have a lot of infrastructure in place to support this. There's voltage drop concerns. You want to keep those conductor sizes of the wires small, so you typically try to deploy that power as far out into the facility as possible. That's usually fed by a secondary breaker upstream from the critical switchgear or UPS power output. And that's, majority of the facilities that were built up until probably about 5 or 10 years ago deployed this type of topology for their power distribution. And, there's some issues with that. So there's challenges from a power perspective that I want to discuss today as well. So just the flexibility aspect of it, it adds a lot of complexity to it. Circuit additions sometimes become very difficult. As you can see there in that image on the screen, unfortunately, especially when you get closer to the RPP or PDU equipment, you get just a sea of cables there, and it becomes difficult to add additional wires if you're adding more cabinetry onto the floor, doing any work there. Location of new breaker panels or positions. A lot of times this infrastructure becomes fully utilized, and then you run into situations with, once again, looking at it from a modular approach, how am I going to add additional equipment here to be able to support the growing needs of my facility? And that was really one of the things that we'll talk about in the Shands installation later on here. They were really looking at this from a perspective of, okay, as I grow, how am I going to incorporate a lot of these things, not being limited by some of the traditional power distribution scenarios that they had seen in the past? And pulling wires, circuit verification becomes an issue as well. So you're relying upon cables being labeled correctly onto the floor, breaker positions in the RPP panels being labeled correctly. So those all add layers of complexity, as well as potential issues that you could run into from a standpoint of turning off incorrect breakers. There's also a lot of challenges from the cooling perspective that you need to consider here. So once again, we talked about all those cables going up into the RPP or PDU units. You can see there in that image, all of that sea of cabling just, runs up in the bottom there. And, you have inconsistent cooling throughout the facility in a lot of these scenarios. The obstructions under the floor, primarily with the cabling associated with this method of power distribution. You have, hot and cold, inconsistent pressures throughout the facility just because of this. Because, if you are going to deploy a raised floor, you want to have consistent pressure under that floor. So, if you have a row of cabinets over by the wall, you're receiving the same pressure there at the perforated tiles that maybe you have over closer to the air conditioning units themselves. So, these are all things that you need to be concerned with. Abandoned cables, we see situations with that where cables are just abandoned under the floor. So it just creates a rat's nest under there that you just don't want to have to deal with. And then anytime you need to do work, just removal of the tile, and then you let all of the pressure out onto the floor, and it's not a good way to do this anymore. And there's a better way to deploy power and utilize some cooling architectures that are more efficient. So just some items for consideration there. And just the modularity aspect, it's just being able to deploy additional pieces of equipment and gear and having a nice, easy way to do that. Sometimes with traditional methods, it's a challenge. What you see on the screen here, we talk about the congestion under the floor. This is a traditional A and B run scenario where you have the RPP units out on the floor, the larger PDU units. And then in an A and B scenario, this would be the required cable whip deployment to be able to feed that row of cabinets that you see there. So if you just think of the mass of cabling, infrastructure that you need to support this, it becomes definitely cumbersome to manage. And then on the other side, if you think about an overhead power distribution utilizing a busway type topology. In this scenario, you have an A and B PDU feeding the busway runs. Right at the end feed, larger ampacity breaker is typically installed in the PDU, feeding whatever ampacity of busway that you're deploying. And then utilizing the plug-in unit scenario, you plug the plug-in units directly over the point of use. So you can see you're tapping off power there directly over the cabinets. And it's a much cleaner way to do it. And then all of that other infrastructure that you needed on the floor in prior topology, you save for actually what the data center was used for, which is cabinet space. So it's really a much better way to deploy power on the data center floor. What you see here, we continue to see an emerging trend going to overhead power as well as no raised floor. So in this scenario, this was a joint installation, another joint installation we did with Chatsworth, where no raised floor was deployed. And chimney cabinets were also integrated here for exhausting the hot air into the plenum above the ceiling. Also, the end user here utilized the different color of the plug-in units to designate between A and B. So once again, removing any or minimizing the potential there for error where you're pulling power off. And it's just a nice, clean way to deploy power within the facility. So some of the benefits here, the one thing that we talk about is the elimination of the raised floor. So there's a nice cost reduction story here that you can tell, as well as the modularity aspects of things. So, significant cost of the data center facility on the construction side, both from a cost and a time perspective, is the implementation of the raised floor. So being able to remove that from the design can definitely be a benefit to you. Reduction of the expensive equipment as far as minimizing or potential elimination of RPP units and then lesser PDU units on the floor also creates another savings perspective, as well as saving the space like we talked about before for additional cabinet deployment. And then once again, creating a scenario that's easily configured or structured for growth. So adding that modularity aspect into the design is definitely something that the organization can benefit from. So why is all this occurring? Steve and Warren talked a little bit, just all the changes that are occurring in the industry, different things that we see here, in our daily struggles with managing these facilities. The increased power densities are really causing issues and requirements for change here. So, those are all things that you need to take into consideration. Seeing the KW, especially in larger, dense rack scenarios, 10, 15, 20 kW per rack is not unlikely anymore. And because of that increased density within these cabinets, there's a need for improved cooling strategies. And the need to deploy scalable and modular approaches to these scenarios. These facilities are changing quite a bit, so being able to adapt to that change is definitely something you want to take into consideration. Data center consolidation. We continue to hear about this as well. It's a huge issue in the industry. People are trying to be smarter about running their facilities, where they maybe had 3, 4 data centers across various sites before. You have fixed costs associated with running those, and getting down to a manageable level and designing these facilities for smaller, more dense applications is definitely something that we're seeing. Server virtualization, moving things to the cloud, they're all driving the changes that we're seeing here. And then also the energy savings initiatives that we're seeing out in the field. That's definitely something that people need to be continue to be cognizant of, and how those things are going to affect their own facility. So just to talk in some of the benefits of deploying an overhead busway scenario. So just once again, adding the flexibility. One of the things that's great about these types of deployments, especially our product, is the ability to add and remove circuits live, especially the fastness of this. So you don't have scenarios where you're waiting for an electrician to come in, reduction of issues potentially from performing work in RPP or PDU units live. That's an issue that we continue to hear about. So being able to add those circuits and as quickly as you can, and without de-energizing the busway, is definitely a benefit. At the energy efficiency, so once again, you're removing all those cables from under the floor. Your cooling acts in a much more efficient scenario, and you have consistent cooling throughout the facility. The scalable and the modular approaches, just being able to incorporate those, like I said, that's something that's huge now. And just being able to give these facilities a longer run life before refreshes is something that you want to consider. The configurableness of it, we continue to see, and this is another thing that we ran into with the Shands installation, just having multiple load requirements for cabinets that are right next to each other. So, single phase versus 3-phase loads is definitely something that's a much easier scenario, because you can pull off exactly the power that you need from the bus. And then the lower cost. So generally lower material costs from what we see, and then definitely the labor savings perspective day one. But then over the duration of the facility, we see significantly lower operating costs than traditional methods. So, and then also being able to limit some of the equipment that would be unnecessary in these type of deployments on the raised floor. Being able to expand the facility and redeploy the facility. So we've actually seen in refreshes recently where our products had been installed previously, and they were able to take those that busway down and redeploy it in the new facility or after they reconfigured the space. So once again, being able to give a longer runway for these facilities and be able to reuse them and the products, and it just is a much better way to do it. We talked about the reduction of human risk. The nice thing about this too, typically the bus plugs are installed directly over the cabinets. So you have a very easily visual scenario. If I need to do work within this cabinet, I know I'm shutting the breaker off for the cabinet directly below where I'm doing the work. So just any time that you can reduce that potential risk of human error is definitely beneficial as well. So, all things for consideration here, and like I said, we definitely see this as an emerging trend. Typical busway layout system. So once again, you have the power feed where you're incorporating the feed from the upstream PDU unit. We have housing sections and all the necessary piece parts to deal with any potential obstructions or layout that your facility may need. With T-sections and elbows and different things, it's been also easily implemented in scenarios where you're using containment or other cooling strategies where there may be infrastructure overhead that you have to either get around or work through. Traditional scenarios, this is a typical layout. We've all seen these types of facilities. The cabinets, of course, are depicted in the blue with the X's, and then the bus runs, A and B runs there in the light green color. So once again, nice, clean, easy way to deploy the power within the facility. If you think about an RPP or PDU scenario with whips under the floor, that would be an extremely messy scenario under the raised floor to feed all of those cabinets. So once again, thinking about the modular approach, the flexibility and the customization aspect is definitely something else that we want to keep into consideration here. Having other ways to feed the bus, so top feeds, bottom feeds, terminal blocks utilized to fully load, bank test the bus before it's turned up, and you bring in your critical loads. Those are all necessary piece parts to the puzzle. We've seen scenarios too where you have height requirements. So that bracket that you see there on the lower right-hand corner of your screen was actually a bracket that we designed for implementation of bus on a Navy ship. As you can imagine, they had deck height issues, and then once the cabinets were installed, there's a very minimal space between the top of the cabinets and the deck height above, and they were looking for an A and B run on a very small envelope. So once again, having that flexibility, that modularity design, and get a lot of power in a very small space is definitely something that was able to benefit the end user. So just to talk about some typical plug configurations, we're seeing stuff across the board, anywhere from fused to breakered scenarios, drop cords with pin and sleeve, receptacles in the plug-in units. Once again, just being able to provide a customized solution to people and pull off exactly the power that they need, for their facility, and also be able to accommodate changes in the field, definitely give you a longer run shelf life for your facility. So those are some things to consider there. This image that you see is actually was another slab on grade scenario with in-row cooling units, and we were able to feed this scenario with a top feed scenario as well as the plug-in units to feed the cabinets, dealing with some of the infrastructure overhead. You see the ladder tray there and some of the other cabling for the in-row cooling units. It was a little bit of a challenge, but once again, being able to deploy these in scenarios, especially retrofit applications or refresh scenarios, deal with a lot of the infrastructure that's still overhead, whereas before you might not have been able, or at least considered, deploying power overhead because of some of these issues with your infrastructure. So before you think that it could not be deployed, definitely take a hard look at your facility, and maybe some of these topologies can be deployed with some of the newer designs that are available today. One of the other scenarios, busway and modular designs, and Stephen Bornfield will get into this a little bit in his next part of the presentation, but, we all think about pods when we talk about modular scenarios. Modular means a lot of things, and, busway can be deployed in even the smallest scenario. So you can see there the image on the right-hand side. The busway was deployed for some pretty dense racks there, small racks, and then the plug-in units were designed to fit in, same thing, in a very small envelope. They were actually much longer than what we typically do from a plug-in unit perspective. So once again, being able to customize and deploy a tailored solution specifically for the customer's application is something that you definitely want to look for when considering power distribution. The other thing that we continue to see, and it's on everyone's mind, is the monitoring trends. Once again, we talked earlier about the situation with being able to track power usage and understand your facility and how that is incorporated, being able to get revenue grade metering from both an end feed to monitor the entire busway run, and then at your rack level is definitely something that we continue to see trending in that regard, and it's actually been quite substantial over the last couple of years. So definitely something to consider there, and then being able to ingest that data and make use of it. So look for common platforms, SNMP on Ethernet side, Modbus RTU are all scenarios that we think that this is a much better way to deploy your power scenario. So in summary here, just why overhead power is better. So just being able to tap off power anywhere along the bus to meet the maximum flexibility of the scenario that you're deploying. Just the willingness for customization, just look for that and how that might benefit your facility from a modularity perspective. The faster installation, reduction of human error, plug-in units being installed quickly, and the reusableness of the products and ease of design and layout are all definitely something that we feel will benefit your facility in the long term. So with that, I will pass it back to Mr. Stephen Warren, and thank you.
Mark, thank you very much. A tremendous amount of information. I got to say, look at the questions. We've got a lot of questions from folks. This is great. I do agree that some of them will not be able to be done right now, so we'll take them up during the roundtable. So if I could, I really want to turn things over to Stephen. That was a perfect intro. Stephen, we're hearing these words: modularity, scalability, flexibility, along with efficiency, but also it's got to take care of the past, that legacy, and at the same time, Stephen, it's got to take me into the future. New technologies, new requirements. Take us through this and also begin to take us into more of what was done at HealthShands. Thank you, Stephen. Over to you.
Thank you all very much. Appreciate it, Mark, Stephen. So a lot of times when we think about modular design, most of us start to think of like a containerized solution. And we feel that this is what we're looking for our data centers. While these do offer some benefits, there's a lot of challenges associated with utilizing this sort of an application. So really what we're going to be talking about in this discussion really has nothing to do with containerized data centers. It's more of a modular design approach. And what we're doing is we're trying to go through and think of things a little bit differently. We could be thinking as a module down to a cabinet level, or it could be to an entire aisle setup, or it could be an entire space. And for this discussion, it's really based around an entire space. It's trying to take into account all these different challenges that we have out there around modularity and understanding what we can do to make those work within our facilities. One of the things whenever we look at modularity, we really need to think about that planned growth or what we're going to be doing and kind of setting these standard sets. How we can make this work with anything from converged systems, so these that are integrated with compute, network, storage, bringing that all into one, shall we say, block. Then also understanding some of the loads and then trying to figure out, well, maybe we don't go converged. Maybe we still stay with the separate compute, separate network, separate storage. That's really where we were with SHANS, and a lot of the things that we focused on, we're trying to go through and look at that and understand what do we need to do. Because we're designing for today. We're trying to look at today, but we're projecting what the future is. What are we going to need to do for that? What are we going to need to do to support the power, the cooling, increasing the energy efficiency, understanding what we can do to kind of make this like a cookie cutter, but at the same time going through and trying to address this as a standard block. Most of our designs we try to make flexible. But we're projecting for something that's 3 to 4 years before we ever get to the beginning. So we need to really think about what we're going to do. What are the future technologies? What are going to be the equipment, power needs, cooling requirements? Are we going to be able to support front to rear breathing, side breathing? There's a lot of devices out there that breathe from the rear forward. We need to go through and make sure we can maintain and, shall we say, project or protect those sort of things. And really, is it easily integrated or upgradable? Whenever we think about these things, we always think about, well, yeah, we can do this today, but 1,000 days down the road, what are we going to have? So we need to always be able to support our network connectivity, all the different challenges around those sort of connections, being able to really understand what our footprint requirements are going to be. If we look at a lot of the new products coming out there, they're massive. They require a lot more space. If you look at like the Cisco 7018, 9018 switch, that cabinet is almost a meter in width due to Cisco's requirements for clearances. So whenever we think about a modular design, we're thinking about a planned or controlled growth. We want something that's easy to implement, maintain, install, but also we want something that we can help maintain our standards, increase that. And all these things will help the IT managers be able to work with their resources, their growth, and being able to understand that. Whenever we went into US Shands, one of the first challenges we had was we were going in there and they had an existing legacy data center, raised floor, very standard operation, power under the floor. They were starting to transition their network overhead. And they were also having some other spaces that they had, and there was some challenge around, do we go through and improve one of the existing spaces, or do we build a new space? And if we built a new space, how would we do that? And a lot of these things were looking at, okay, how can we make this happen, but also reduce down the total number of spaces or footprint that is out there? And we were really looking at that as well as driving the energy efficiency, making sure that we can go through and support their current needs, but also their future. So whenever we were going into this, we were looking to figure out ways that we can handle all this expansion and being able to understand that today's network requirements are changing. There are needs for electronic records. A lot of the doctors are now, as well as patients, are using handheld devices. Being able to integrate in both wired and wireless surgical devices. These devices are creating a huge demand on networks that we never had in the past. And so we were having to look at that, but also we need to support what we had today, but in the future. So whenever we looked at this and understanding, we wanted to make sure that the system would be able to manage day 1 to day 5,000, hopefully. And we would never have to have facility personnel coming in to interface with the equipment and being able to make that change so we could make it automatic in essence. And being able to support this future cabinet install and the power needs. So in this data center that we designed for Shands, we actually were able to go through and do that. Yes, if many folks look at it, they'll say, well, wait, you've got everything installed. Well, yes, we do have a pretty solid infrastructure in there. All the cooling's in there. All the power is there, so we have that capability. But one of the most significant changes that we had from whenever we looked at Shan's original space to their new space was being able to go through and support the future loads. Their load increase has more than doubled what they originally had in their space. So they wanted to go through and understand how they could support these growing loads. In this new space, we can support over 18 kilowatts per cabinet. That was unheard of in any of their existing spaces. But also they wanted to be able to bring in non-standard equipment. So if they had a cabinet that really they couldn't go through and re-rack the equipment into whether it's a chimney cabinet or a VED, they could go through and put that into a hot aisle solution. So we were able to go through and incorporate both into the design and make it where they had that flexibility and being able to support their future need, that growth, and do this all without having to add additional cost. Well, this really helped them in being able to work to that future, and it gave them ability to, shall we say, modularize their data center. Now, whenever we think about it, each person's interpretation is different on what a modular data center is. And a lot of it comes down to, what do you need? Everyone wants to turn and say, you know what, I'm right now this is what I'm installing. But we don't know in a year down the road what we're going to possibly be bringing in. There could be new applications, new systems, all those sort of things. I was at a customer site just about a month ago, was bringing in a new server that had drives on the front and the rear of the device, but it had air intake midway through the device. So it wasn't a true front to rear breathing. It was not a true side breathing, but it had these needs to go through and work with all this different emerging technology. So we were able to come up with different solutions for them as well as for shams. We can plan for that future growth, that flexibility. The space has been in operation for over 2 years. They've been able to continue to bring in the new devices, be able to support the new applications. But the real significant part of this is we were able to increase the efficiency of the data center, but as well as we were able to help shams in being able to come up with a way to forecast their future growth, both in cost as well as in resource needs. And so with this, we gave them an easy path with the Starline bus rails so they could get the power distribution. And then also we were able to come up with different solutions for their install needs for the new devices and systems. So a lot of this was a team approach, working with our designers, coming up with new innovative ideas, and working through things that we could do very differently. So that's really where we were with this.
Stephen, thank you so much. Really encapsulating a lot of the things that even Mark was talking about and bringing us forward. So before we move forward with Joseph, I thought it'd be a good time now for us to bring up that second poll question. So folks, please jump to your voting. We're going to launch the poll question now. That is, what is your preferred approach to managing cooling in your facility? Hot aisle, cold aisle orientation of cabinets only, no containment or closed loop cabinets. 2, hot aisle containment. 3, cold aisle containment. 4, individual closed loop cabinets, or a combination of 2 or more of the above. Which is interesting. I mean, Stephen, one of the things that you're saying, and we've heard a lot from everyone registering for this fantastic webinar, is they're seeing tremendous challenges in new technologies, new zone requirements. They're really taking a look at everything that's needed inside, but it's difficult to look forward to that new technology. I'm sorry, Stephen, you and I both don't have that crystal ball, and if we did, I think we'd be billion-dollar winners now in Lotto. So let's actually take a look at where we've been in this voting for what is your preferred approach to managing cooling before we turn things over to Joseph. That's pretty interesting. Well over 50%, 54%. Everyone's using combinations of 2 or more. We're then seeing a next ranking, hot aisle containment, followed by cold aisle containment, perfectly matched. And then coming in fourth would actually be that hot aisle, cold aisle orientation of cabinets only. So no containment. Very, very interesting. You know, Joe, let me turn this over to you now if I could, please. And at the same time, I'm going to ask both Mark and Stephen if you guys could take a look at the wonderful set of questions we've gotten from the community and think about how we can try and incorporate that into our final roundtable. Joe, over to you. What are your thoughts on this poll?
Thank you, Stephen. The results of that poll are very interesting, and it's good to see that everyone is looking to use both hot and cold aisle containment. You know, there's always a challenge in the data center to build today for what we need tomorrow. Most of us being somewhat analytical, we strive to have as many facts as we can before deciding on a path or solution to propose or pursue. When it comes to building a data center or data center space, we are lucky if we know what our organizations will need over the next 3 years. So, you know, how do we build something that will meet the needs for 5, 10, or more years in the future when we don't know a clue about what technology we need to support? So as both Mark and Stephen have pointed out, flexibility is the key. One of the things I wanted to point out is that we deployed 3-phase via the busways and then used the cabinet distribution units inside the racks, CDUs, to do our load fade balancing so that we keep pushing down to the rack level the modularity and the decision making. We recently had the exact situation where we had planned for it to come to pass. We had a vendor-supplied solution that comes pre-racked, was selected and purchased. And as part of this, I had to have different receptacles than our standard L630 that we had deployed as part of the Busway solution. So I simply called up Starline, gave them the outlet I needed, cord length, and they built it and shipped it to me. My team was then able to, take down the existing tap boxes, install the new ones. This was installed in the hot aisle pod that you saw in Stephen's presentation, and so we were able to also take down the panel, mark it, cut it, fit the panel to the cabinets that they came in, and then reinstall them. No need to contract outside departments or vendors to come in and to work in the data center. It's having the partnership with vendors like Starline and CPI that made this possible. They listened to us as to the design we needed. From the beginning, we wanted to work towards and offer possible solutions based on past experience, which is critical, and what worked well in those past experiences, what didn't work well. This knowledge allowed us to tabletop the learn by error trial period before locking in a design. So I know we have some great questions from the audience, so I'll turn it back over to Stephen so that we can get to your questions, and appreciate everyone's time today.
Joseph, thank you so much. I got to say thank you for also inputting an answer to one of the questions that came up. That was fabulous. Thank you. Hey, Stephen, I want to jump back to you if I could for a moment. This is now we're going to be starting the roundtable and taking some of the questions that we've gotten from the community, 15 already. But at the same time, we've got some other registration questions that had come up from both the white paper, the research, and everything that was done. But could you first talk, Stephen, to the cooling poll and what you're seeing from customers and what you're hearing? It's pretty interesting.
So this is the fun part of this, is that whenever we were going through this in my previous life at Intel, we went through and we did a lot of testing around aisle containment, which one's more efficient, all those sort of things. The really sad part is whenever we originally went through and built our data center, we built a cold aisle containment solution. The cold aisle containment solution works, but we didn't think about our future growth. This was on a raised floor. So whenever we went through and did our install for our initial plan, we were then starting to do the next build. Well, first thing you do, go in, open up the floor, we depressurize the cold aisles that were in operation. We ended up losing that equipment. So we didn't really think about that, and we had to then figure out a way to go through and segregate that. So we did an underfloor plenum to segregate the floor off. Well, that had an impact on our redundancy. So we had a lot of challenges. Whenever folks ask me which one's better, well, from my aspect as an end user running the systems, hot aisle containment. If I open up the raised floor in hot aisle containment, it doesn't impact my cooling capability, so I can go through and do this future build. If I look at the other aspect of it and think about cold aisle versus hot aisle, whenever I go through and create a cold aisle containment, I'm creating a box, in essence, in front of those cabinets. And that box has a specific amount of air capacity to it. If I have the slightest hiccup in my air system, or if I all of a sudden start to see a peak, I could actually undersupply the amount of air needed and overheat devices. So the challenge with cold aisle containment is it has that limit there. Whereas hot aisle containment, you could provide more than 3 times the amount of air volume in the space to cool devices, so you could actually go through and ride through some of these hiccups that happen. And this is the regular thing that happens within our data centers. So from my perspective, I'm a hot aisle containment person. Now, whenever I was over in Europe, I couldn't understand why there was so much desire for cold aisle containment. And a lot of it came down to their elevation. They had a very tight slab-to-slab elevation, and it was very hard to incorporate in a hot aisle containment and create that return plenum. The fun thing about this is that I've done quite a few data centers that are actually in spaces that everyone said there's no way you could go through and do this as hot out containment and create the return quantum. And I've been able to make it work extremely well. And so this is where, yes, we do a lot of things around doing different, not the same cookie cutter, but at the same time, we try to get to that modular approach and consistency.
Stephen, thank you very much. I actually want to jump back to you, Mark. We've got a tremendous number of questions coming through, a limited amount of time, and yes, we will be responding to these questions. Both Starline and Chatsworth will respond to all of these. But, Mark, I wanted to reach out to you first before I talk to Joe. Let's talk about this partner. Let's talk about legacy. Okay, let's jump to legacy right now. A lot of people are dealing with legacy equipment, but at the same time, legacy solutions, legacy infrastructure, underfloor that they can't get away from, raised floor that they can't get away from. But at the same time, you talked about this. New technologies coming down the pike, new things that we haven't even seen yet. Even when we're even talking about SDN and MFV, this is changing all of our networks too, just as all the new application engines are changing our racks. Can you talk about dealing with these challenges, and at the same time, some feedback on some of the questions that have come up from the community? Please, Mark, over to you.
Well, yes, definitely. Thanks, Stephen. We see situations like this all the time. Unfortunately, it comes time for a refresh, and a lot of times the end user is shackled with whatever infrastructure they have in place there. Hopefully just limited by size of the existing facility, and maybe they do need to keep the raised floor. We've even seen scenarios where they have to they're out of power. So say all the RPP or PD units are full, and they need to bring more gear in there. And while they grow and expand, they can't take down what they have today. So they need to kind of run a dual scenario for a while. And actually, one of the benefits of deploying Busway is, if you are using underfloor today for power distribution, a lot of times you can come in, install the busway overhead, and then start to cut over things live, or in planned outages and things like that. So you do have the flexibility to do that. So yeah, we are seeing a lot of these legacy facilities that either are needing to be upgraded just because of limitations of the infrastructure that's in place, or they're going through and going through a refresh of that space. So yeah, definitely see that. One of the questions that did come up, I thought this was interesting, was have we ever deployed busway under a raised floor? And definitely we have. And actually, probably the largest installation that we did was actually the commodities trading floor in Chicago. So what you run into there, depending upon the size, the infrastructure that's under there, those types of things. Yes, busway can be deployed under a raised floor. And they also asked about the code requirements for that. And typically what it comes down to is the local inspector interpretation of the code. So we've run into situations where they haven't deployed that because of the local interpretation by the inspector. But more often than not, we've been able to work with the end users if that was the desired approach to deploy it under a raised floor. And like I said, we do have a lot of installations in that type of environment. One of the other questions that came through, Stephen, was as far as highest ampacity of bus that we have available, and that would be our 800 amp product. And we have ranges, but primarily in these types of applications, the big ones that we sell into this space, we have 100 amp, 225, 250, 400, and 800. Those are kind of the ranges of bus that we have available for these types of applications. Back to the legacy question. One of the other things, and Joe Kina talked about this during his discussion there, is the partnership approach with your end user. And that's really something I know that CPI tries to do. They really take a consultative type sale, looking at holistically at the implementation of the facility and bringing in a lot of companies that they recommend, outside of their traditional product line to be able to really meet the needs of what the end user is trying to accomplish there. So once again, having that partnership and just talking through about one of the legacy aspects that we've seen, there was an end user, a joint customer of both ours and CPI's that wanted to deploy Busway, and they had, once again, height issues in the facility and could not install the Busway overhead. So actually we jointly developed bracketry that hangs on the back of the CPI cabinets to be able to hang the Busway off the back of the cabinets as well. And once again, just looking at trying to get creative, determining customized solutions to meet the needs of the customer are definitely something that's in all of our wheelhouse. And we really try to do that. And like I said, a lot of those things were really designed to deal with the legacy type issues. So, yeah, we continue to see that, and I will imagine that we'll continue to see that for a long time to come.
Thank you. Joe, I got to turn this one over to you also, because let's talk about it. For 2 years, you've been running this solution, working with them together in partnership. But during that 2-year period of time, you're dealing with some new legacy issues, and you're talking about new technologies too. And also, Joe, I've got to get your thoughts on this partnership and how critical it is, because, my God, you are mission critical. You need to have these people there getting your back. So, Joe, please, over to you, your thoughts.
Yeah, absolutely. Thank you, Stephen. As Mark was pointing out, the partnership is key in developing any space, whether it's for a hospital or any other institution, banks or anybody. Our organizations depend on us to make sure that the equipment is up and running and available. So that all starts with your design and your power delivery and your cooling delivery. So it's critical to have those pieces in place from the beginning. So, we've, as Stephen pointed out, we've doubled our load in there as we've been able to move legacy equipment in from other locations. We consolidated a couple of smaller data center spaces into this. That was the plan all along. So, but as I pointed out, we had a brand new system come in. The solution said it had to come in its own racks with its own PDU requirements, but, it didn't throw us any curveballs because we were able to quickly, go into the hot aisle containment that we had deployed already and, change the Starline taps out, and we were ready to go. So, that was the proof of the partnership and the flexibility that we designed in there, was that we were able to take that request from the organization and deliver on it without having to go back for, a lot of rework or a long delay in having that deployed to the organization.
Joe, that's really interesting. This is also multiple sites, because I understand, Health Shands is monstrous. You have multiple facilities, multiple hospitals, multiple clinics. You're dealing with a lot of different elements here, and can you almost have it all? Are with this new design strategy that you've come up with Starline and your other partners and Chatsworth, have you really been able to see a much smoother ability to implement much more flexibility?
Absolutely, Stephen. That was our goal, was that we knew that we didn't know what was going to be coming down the pike, but we had to be able to quickly execute on anything that they wanted to bring in. And, as we brought on a new electronic medical record, we're bringing in the different modules of that over time. That requires refreshing that equipment. As everybody knows, there's no such thing as a true pull-push. You're always doing a push-pull. You have to push the new one in before you pull the old one out. So you have to have that swing space, that flexibility. So new storage. All of us, I'm sure, are dealing with storage growth. So the ability to either put it into the racks that I already have, or be able to bring in the custom solution that a vendor is proposing. We have that flexibility there. And then, the other thing that, of course, all of us are working towards is virtualization. So you're looking at those, putting more and more into fewer and fewer racks, but that virtualization then extends the life of your data center, and so the flexibility of the modularity that you've designed in becomes even critical, because now you're going, 2, 3, 4 years longer than you expected to go in that data center space.
That truly is a return on investment and flexibility. Absolutely, Joe. Thank you. Mark, I got to turn this over to you. I mean, you take a look at these questions, Mark, and you're seeing a lot of horses for courses here. You're seeing a lot of requirements of, can I have it all? I've got very different requirements. Could you touch on some of these elements for us? And at the same time, talk about this legacy issue, but it's almost like a legacy issue now that you have right now.
No, definitely. You know, we continue to see these hybrid approaches. You know, we back to the poll question with a hybrid scenario where you're deploying different cooling strategies, a hybrid scenario where you have high density racks, low density racks, hybrid scenario, new data center, old data center. I mean, there's just a whole mix of things that people are dealing with out there. And once again, just having the flexibility to deal with those. You know, we continue to see more and more scenarios where people are deploying even different busway products within the same facility. So you'll have a run, you know, where they'll utilize potentially our 225 or 250 amp product, and then in the high density 400 amp product or the 800 amp products deployed. And once again, you know, myriad of plug-in unit combinations where you're, you know, 208 scenarios, 12208 scenarios, or a lot of the larger facilities now are going to the 400 or the 415 volt installation. So really just, you know, a myriad of hybrid type applications out there, you know, being able to deal with the legacy stuff and the new. It's just, this is what we're all dealing with. This is where we're living today. And like I said, just being able to deal with the issues today, but then also try to incorporate some of these approaches to be able to make the facility usable for the long term is, you know, that's where everything's going now. And, you know, we're really trying to assist the end users to be able to meet that need and that requirement. And like I said, I don't see this changing anytime soon. One of the other questions that came up, poll questions, and I think it's important to just touch on this quickly, is the arc flash and the performing live work. And, you know, one of the things, and when you're evaluating a busway, one of the main items that you want to take into consideration is, you know, is this bus listed as hot pluggable? And there's a UL standard for busway products. It's actually 857. And our products are all tested and meet the requirement for live insertion. So there's a listing component of this. The nice thing about our plug-in units, they're grounded before the phase bars are even engaged from the plug-in unit perspective. So anybody who's doing work can be guaranteed that the plug-in units are grounded before any phase connections would be made. Then there's the NFPA portion of this, which is the live work component. And the recommendation that we always give is, you know, firstly, there's an element of criticality with the gear that you're working on. Is this a critical load? And if so, then you know, then you can make connectivity to that live from a power perspective. But you also need to understand your arc flash potential there. So, you know, we, as part of the scenarios, always recommend to the end user that they understand the incident energy depending upon their power architecture that they've deployed in the facility, and then that their workforce wear the appropriate PPE based upon whatever that arc flash calculation comes back to. So, yeah, it is fully listed to be able to do the work live. And just like I said, understanding that and then wearing the appropriate PPE to insert those plugs live is all you really need to do to be able to utilize being able to deploy plug-in units after the system's deployed. So, back to you.
Thank you very much. Mark, thank you very much. Better ending when we're talking about a fantastic deployment at a health and a hospital group when you talk about health and safety. Stephen, I'm sorry to do this to you, but I've only got about a minute for your final thoughts. What do you got here for us? I mean, we're seeing, if you take a look at these questions, we're really dealing with people who have got very, very different issues, different challenges, and different situations that they're dealing with. What are we doing here?
So there's a whole bunch of different questions out there, and let me just real quickly breeze through some of them. In maximum kW load, I've actually had installed loads of over 30 kilowatts in the cabinets and been able to support them without any issues. I know Starline's been able to actually support over 45 kilowatt load in a single cabinet. there's not a challenge going to that load. So there is a lot of flexibility there. If we look at the code issues, honestly, we eliminate a lot of the code issues going to Starline bus rail, and it gives you that hot swappable capability. This is one of the few products on the market that can do that. So it really helps in being able to go through and support those sort of things. And if we really think about the future growth and how we do these caps, the really neat thing is that this does give you the ability to plan your future, go through and get the proper supply, shall we say, to the point of need. And it's at a much reduced footprint than what you would normally see. One of the challenges we've always had whenever we go through and look at these spaces is that we can't go through and support the future because of we're out of space. Well, the neat thing is with Starline, we take that footprint off the floor.
Well, thank you all very much for joining us. And at this time from Data Center Dynamics, we look forward to seeing you at one of our upcoming events this year, and join us on more of our webinars. But more importantly, connect with Starline, connect with Chatsworth, and get engaged with these guys. The solutions are there to meet your challenges. Thanks for joining us today, and have a wonderful day.